So question 9 from Unit 5, review, asks how fast is the rock by the time it has fallen to a height of 2 meters? And what's happened is the rock started up here and then it falls, and it started from a height of 25 meters. And we know that it has a mass of 320 grams. And so when it's first dropped, when it's first here, its total energy is equal to potential energy plus kinetic energy. And at the top there, the potential energy is mgh, and it's not moving, so that is 0 joules of kinetic energy. So the total energy at the top is the potential energy, and it has a mass of 320 grams, and we need that in kilograms, so we can convert that to kilograms. Kilograms are larger, and there's 1,000 grams in 1 kilogram, so those are cancel out, and then we multiply this by 9.81 newtons per kilogram, and the height is 25 meters. Okay, and when we do that, then we can calculate that up, and we get a value of 78.48 joules, and that should have been your answer to number 6. So that's the total energy, and as it falls from here down to here, that's going to be the total energy it has every time. Now, down here at a height of 2 meters, it's going to have some potential energy, but it's also moving, so it's going to have kinetic energy. Okay, and question 9 is asking how fast is it by the time it has fallen to a height of 2 meters. Okay, so at 2 meters, same scenario. It has potential energy and kinetic energy. The total energy is this. The potential energy is going to be equal to mgh, okay, and kinetic energy is 1/2 mv squared. We want to actually find the velocity, so we're going to solve this thing for velocity. So I can go like this: et minus mgh equals 1/2 mv squared. And if I want to get v squared on its own, right, I want to get v squared on its own, so I'm going to divide both sides by 1/2 m. Okay, so et minus mgh equals v squared, and if I'm dividing by half, that's the same as multiplying this whole side by 2, and then I'm going to divide by mass. So this is the formula we're going to use to figure out velocity squared, and then we're going to take the square root of that. So we'll just move that up. So we can start putting in numbers. 2 times the total energy was 78.48 joules minus mass 0.320 kilograms, which was the 320 grams, times g, 9.81 newtons per kilogram, and the height at this point is 2.0 meters, and we're going to divide that by the mass, 0.320 kilograms, and that is equal to v squared. Okay, so v squared is equal to this, so I'm going to calculate that. And so that's equal to 470.88 joules. Sorry, not joules. Not joules. It's actually equal to, and it's not obvious from this, but we know it's velocity squared. So velocity is meters per second, so I can just square that like that. So it's meters squared per second squared. Okay, and if I want to figure out the velocity, then I take the square root of both sides, and so the square root of this meters squared per second squared, and the velocity then is 21.69 or 21.7 meters per second. So that's how these are solved. There's quite a few steps here. You need to understand that the total energy is always like this. Every type of question like this, right? And then once you know the total energy, then if you know the height, you can figure out the potential energy. Or if you don't know the height, you might know the velocity, and you can figure out the kinetic energy. Right? So as long as you know two of these things, so maybe you know the total energy and potential energy, then you can figure out the kinetic energy. Or if you know these two, you can figure out total energy. Right? But that's the process it's going to take for these. Okay? So hopefully that was helpful.